Alright, at the heart of chemistry class is unit conversions. Nearly every problem you work from now on is going to involve at least one unit conversion. Not only that, but the thought process that you use for unit conversions is really the secret to working all of chemistry. If you can work a unit conversion, what I am about to show you here and now, you can do 50% of the course material, no problem. So let's get started. Let's take a look at a basic unit conversion. How many millimeters in 9.0 times 10 to the 8th meters? Whenever I'm working a unit conversion, the first thing I do is I ask myself, what do I know about the units involved? In this case, I know a direct relationship between millimeters and meters because I've memorized it. I've memorized that 1 millimeter is 10 to the negative third meters. Remember, I'm telling you to memorize your prefixes in such a way that 1 always goes with your prefix, power of 10 with the unprefixed unit. So 1 millimeter is 10 to the negative third units. Next, what I'm going to do is I'm going to start a line. One of the great things about chemistry is most of the time when you work a problem, they're going to throw a whole ton of numbers at you. But a lot of those numbers will actually be unit conversions they're giving to you in the problem. So identify a number in the problem that's not a unit conversion. Well, there's only one number in this problem, so it's really easy to know what number I'm going to start my line with. So what I mean by start my line is I'm going to write 9.0 times 10 to the negative 8th meters. I'm going to draw a line underneath it and then a vertical line. What I'm doing when I'm drawing those lines is my vertical line here represents a multiplication symbol. My horizontal line here represents a division symbol. What I want to do now is I want to place whatever unit is right here, I am going to place right down there so that it divides out. I have meters here, so I'm going to write meters down there. Whatever you have here automatically goes down there. What do I know about meters? I know that 1 millimeter equals 10 to the negative third meters. So I keep the numbers with their units, 1 millimeter, 10 to the negative third meters. So now I've placed it so that my meters have canceled out and I'm left with units of millimeters. Hey, that's the unit I'm wanting for the problem. So now I just have to multiply everything on top, divide through by everything on the bottom. And when I do that, I get 9.0 times 10 to the negative 5th millimeters. This example also provides us with the opportunity to review a couple things. First, let's review our operations. 10x divided by 10y equals 10x minus y. 10x times 10y equals 10 to the x plus y. Why do I say this to you? Because when working with a metric system, you can often avoid a calculator. Right? To do this, all I had to do was go negative 8 minus a negative 3 is the same thing as adding a 3, so it's a -5. So that's one piece of information that's useful to review. Another piece of information that's useful to review is another way of looking at this line here. Some people think the line's a little bit confusing, even though it's in vogue and 90% of the chemists out there use it. But what I'm really doing is I'm really writing a ratio with my line. I'm really saying where this multiplication symbol is the intersection of my lines. So that's all I'm doing with this line here. If you didn't get that answer out when you put it in your calculators, see my calculator instructional video, and if you still can't find that, then feel free to ask. Why don't you write down Pinky, P-I-N-K-Y, Pinky, P-I-N-K-Y, and then look at my next example. How many joules in 4.2 times 10 to the 4th picojoules? Alright, first thing I want to do is write what I know about those units. I know a relationship between picojoules and joules. I know that 1 picojoule is 10 to the negative 12th joules. Next, I want to start my line with a non-unit conversion in the problem. Well, I only have one number in the problem, so it's going to be real easy to start my line. I'm starting with units of picojoules. I don't want units of picojoules, so I'm going to place picojoules where they cancel out. I'm going to place joules, which is the only thing I know about picojoules, right above it. Keep the numbers with their units. There's a 1 in front of the pico here, so a 1 goes there. There's a 10 to the negative 12th in front of joules there, so I place a 10 to the negative 12th there. I've canceled out my picojoules, so now I'm going to multiply everything on top, divide through by everything on the bottom, and I wind up with 4.2 times 10 to the negative 8th joules. Alright, let's kick this party up a notch by writing down the word brain. Kick this party up a notch by writing down the word brain. But you knew that was coming after Pinky anyway. Pinky and the brain, Pinky and... But anyway, how many kilograms in 3.99 times 10 to the 8th femtograms? Same process as before. Write down everything we know about the units. Do we know a direct relationship? Do we know a direct relationship between kilograms and femtograms? No, we don't. We do, however, know a relationship between kilograms and grams and femtograms and grams. All right, now start your line. With the only non-unit conversion number in the problem, 3.99 times 10 to the 8th femtograms. Do I want femtograms? No. So I'm going to place femtograms where they cancel out. The only thing I know about femtograms is the relationship to grams. So I'm going to place grams up here. Keep the numbers with the units. 1 femtogram, 10 to the negative 15th grams. I don't want grams though, so I'm going to keep the party going. I'm going to take my grams and place them where they'll cancel out. I've already used this unit conversion, so I don't want to use it again. Hey, I have a relationship between grams and kilograms. 10 to the 3rd grams is the same thing as 1 kilogram. So I've canceled out my grams, and now I'm going to multiply everything on top, divide through by everything on the bottom, and when I do that, I get -7, -10. 3.99 times 10 to the -10th kilograms. So this was the exact same thing we did the other 2 times, just a step longer. The secret to working unit conversions or chemistry problems is to continually use this canceling out pattern until you wind up with the unit you're looking for in a problem. Alright, let's take a look at another. How many centimeters in 3.3 times 10 to the third decameters? Write what I know. I know that 1 centimeter equals 10 to the -2nd meters. I know 1 decameter equals 10 meters. Start my line with what I know. Place your units where they cancel out. I have decameters. I don't want decameters. The best thing in chemistry is you rarely have to think about your first step. As a general rule, whatever unit you got down here, you're going to wind up with down there. I know the relationship between decameters and meters. I know that 1 decameter is 10 meters. I don't want meters though. So I'm going to place meters where they'll cancel out. I want centimeters. I know that 1 centimeter is 10 to the -2nd meters. So I'm going to multiply everything on top, divide through by everything on the bottom, and I am going to get 3.3 times 10 to the 6th centimeters. I went from decameters to meters to centimeters. Chemistry's easy, life is hard. There's not a lot I can do to make these difficult. All I can really do is make them a little bit longer. How many inches in 1.44 times 10 to the 8th millimeters, given that 2.54 centimeters equals 1 inch? All right, so we've been given units of millimeters. What do we know about units of millimeters? We know that 1 millimeter is 10 to the -3rd meters. We don't see meters appearing anywhere else in our problem, and I don't know a way to get from meters to inches. However, we've been given the relationship between centimeters and inches. We know that 1 centimeter is 10 to the -2nd meters. So let's start our line with the only number given to us in the problem. 1.44 times 10 to the 8th millimeters. Place millimeters where they'll cancel out. What do I know about millimeters? The relationship to meters. 1 millimeter is 10 to the -3rd meters. I don't want millimeters. I want meters. I don't want meters. I want centimeters. And I know that 1 centimeter is 10 to the -2nd meters. So I place meters where they cancel out. I don't want centimeters, so I'm going to place centimeters where they cancel out. And finally, I'm to inches, where I know that 1 inch is 2.54 centimeters. So I'm going to multiply everything on top, divide through by everything on the bottom, and when I do that, I'm going to wind up with... Alright, that's the fun number of inches that my calculator gives me out. Can that possibly be right? Well, we're converting a measurement, right? So we know sig figs has to come in here somewhere. We have 3 sig figs in our initial measurement. All metric unit conversions, or all SI unit conversions, involve exact numbers. And remember, exact numbers, we don't worry about their sig figs. Here's where things get dicey. Most of the time, English to metric is measured. However, 1 inch is defined now as 2.45 centimeters. So that's actually an exact measurement there. So our initial number of sig figs, 3, is how many sig figs we should have in our answer. So our answer should be, whoa, what did I just do? I was trying to do my shrinky-dink trick. So my answer should be 5.67 times 10 to the 6 inches. If your calculator doesn't do that, then 5, 6, 7, then that's what it would look like if your calculator didn't put it in scientific notation for you. But those be your answers. Let's take a look at the next slide. Before we move on, I want to review exact numbers because for some reason I don't remember talking about them before today. Exact numbers are non-measured numbers. They're numbers you don't obtain by measuring. They fall into one of 2 categories. They're numbers obtained by counting, the theory being that if I were to count the number of hats on a shelf and Joe was to count the number of hats on a shelf, we would both get the same number of hats on the shelf because we're both competent human beings. So numbers obtained by counting as opposed to measuring are considered exact. The other category of exact numbers are numbers that are such by definition. By definition, 1 millimeter is 10 to the negative third meters. There is actually a third category of exact numbers, and those are numbers involved in simple mathematical operations. For example, if I told you were taking 1/3 of a number, or I told you were going to take 1/2 of a number, or I told you double that number, or I told you quadruple that number, right? So a situation where you're taking a measure and doubling it or tripling it or taking half of that number. In those cases, those mathematical operations or operator numbers are considered exact numbers as well. Exact numbers have an infinite number of sig figs, meaning when you're adding or subtracting by an exact number, they will not limit your number of sig figs. It's a fancy way of saying that when you're doing a mathematical operation and you run across an exact number, you don't worry about it when it comes to sig figs. Alright, now let's kill you with examples. The diameter of a nickel is 270 picometers. In scientific notation, express this distance in meters. So basically, we're wanting to convert picometers to meters. Our first step is going to be to write what we know. We know that 1 picometer is 10 to the negative 12th meters. I'm going to start my line with picometers. You know what? Before I even do that, I'm going to convert my picometers to scientific notation. Because I'm working in metric, it'll make my math a little bit simpler. To convert this to scientific notation, I'm going to move my decimal over 2. 1, 2. I'm going to assume that that last 0 represents something measured. So 2.0 times 10 to the second picometers is where I'm starting my line with. I don't want picometers, so I place them where they cancel out. I want meters. 1 picometer is 10 to the negative 12 meters. Multiply everything on top, divide through by everything on the bottom. .70 times 10 to the negative second times 10 to the negative 10th meters. Next example. An all-electric car is made for city driving, top speed of 52 miles per hour. What is the speed in meters per second? Awesome. Okay, first thing we're going to need to do is we're going to need to find some additional information to use here, unless somebody has meters to miles off the top of their head. Alright, I look in a table, I look on Google, and I find that 1 mile is equal to 1.609 kilometers. So that's one thing I now know. I also know that 1 kilometer is 10 to the third meters. Then it looks like I've got some time here. I know that 1 hour equals 60 minutes, and I know that 1 minute equals 60 seconds. Now I need to set up my line. And this is the trick to the whole problem, really. Whenever you see per in mathematics, what does per really tell you? It's really telling you you have a division symbol. So if you say that you have units of 52 miles per hour, what you're really saying is that you have 52 miles divided by 1 hour. So when I have a slashed units like meters per second or miles per hour, you have to start your line with the number that you're given and the top unit and divide it by 1 of the bottom unit. This creates a situation where we're going to have to convert a unit on the bottom and convert a unit on the top. For kicks and giggles, since this is new, let's start by looking at that bottom unit. I have hours down here. I need to place the hours where they'll cancel out. Well, if I placed hours here, they'd multiply. So I need to place the hours up here if I want to get rid of them. So I'm placing the hours there so that they will cancel out. What I know about hours is their relationship to minutes. I know that 1 hour is 60 minutes. So I've canceled out my hours because they're opposite each other. So I start off with miles per hour, and I now have units of miles per minute. I don't want miles per minute, so I'm going to have to get rid of them. I'm going to place them opposite again so I can cancel them out. What do I know about minutes? I know their relationships to seconds. I know that 1 minute is 60 seconds. As I flow my units here, I now have miles per second because I've canceled out my minutes. I don't want miles. I don't want miles per second, though I want to get rid of my miles. Well, my miles are still up here on the top. So I'm going to have to place miles down here if I want them to cancel out. Right? The miles are now opposite each other. Or if you want, remember this is how the units really look at the moment. So I've got miles on top, seconds on the bottom. So I've placed my miles where they cancel out. I know that 1 mile is 1.609 seconds. So 1 mile is 1.609 kilometers. I don't know why I said seconds there. So now I've canceled out my miles, and I have units of kilometers over seconds. So I'm still not done. I need to get rid of my kilometers. So I'm going to place kilometers down here where they cancel out. What do I know about kilometers? I know their relationship to meters. I know that 1 kilometer is 10 to the third, and that's a 10, not a 6. Really, so writing with a stylus is much harder than it looks. 10 to the third meters is 1 kilometer. So I've now canceled out my units of kilometers, and I'm left with units of meters per second. Look, see, the only 2 units I haven't crossed off. Since I have the units I want, I can now multiply everything on top and divide by everything on the bottom. When I punch it all into my calculator, I get 52 times 1.609 times 1,000 divided by 60 divided by 60 gives me, whoops, that can't write with that now, can you? Gives me 23.241111 meters per second as the calculator lie. I start off with 2 sig figs here. These are all exact, so I don't worry about them. They're exact because they're by definition. This is actually measured. Most English to SI unit conversions are actually measured. So you technically need to count them in your sig figs there. That would be 4, but 2 is our least number and we're just multiplying and dividing. So my answer should have 2 sig figs. So my answer should be 1, 2, rounding on the basis of that, 23 meters per second, and they're ignoring good sig fig rules and keeping an extra decimal place there. Shame on them. They goofed on that one. The correct and best answer is actually 23. Speaking of 23, why don't you write down good feathers? Write down good feathers. Goodfeather. Good feathers.